Hello, I am Dipti Rangnani, Associate Professor Chemistry, SPC Government College, Ajmer. Today we will study the topic of B.Sc. Part II Physical Chemistry, Thermodynamics. And in this series, we will study the topic thermodynamic properties and exact and inexact differential, उष्मागतिक गुण यथायथ या अयथायथ अवकल. To study the thermodynamic properties, we consider a system having a thermodynamic property Z, and Z is extensive property and it is state function such as energy, enthalpy, entropy, free energy, etc. Suppose this extensive property and state function is the single valued function of many variables such as x, y and z. So we can write z is the function of x, y and z. See in this paper. So these functions are decided the state of the system. If these functions are changed from a to b, that is xa to xb, ya to yb, za to zb, then automatically z will also change, and the change in z is called delta z, and delta z is equals to zb minus za, that is the function of x b yb zb minus function of xa ya and za. Also the exact differential of z, that is dz, is called del z upon del x at constant y and z into dx plus del z upon del y at constant x and z into dy plus del z upon del z at constant x and y and so on into dz. So this partial differential del z and del x indicates that del z upon del x at constant y and z, that is the change in z with respect to x, keeping y and z constant, other variables constant. Also del z upon del y is also partial differentiation, and it also indicates that change in z with respect to y, keeping other variables x and z constant. So dz is called exact differential, and dz, a cyclic integral of dz is also 0. So in this reference we imagine a system, gaseous system, having definite composition, and such as energy, enthalpy is the thermodynamic property of that system, and this energy and enthalpy is the function of any two variables from temperature, pressure and volume. If this internal energy is the function of pressure and temperature, keeping volume constant, then we can write dE is equals to del E upon del P at constant temperature into dP plus del E upon del T at constant pressure into dt. Similarly, if E is the function of pressure and volume keeping temperature constant, then dE is the function of P and V, and we can write dE is equals to del E upon del P into dP plus del E upon del V into dV. Similarly, if E is the function of V and T, last of this page, then we can write dE is equals to dE upon del V into dV and dE upon del T into dt. From these observations, we can conclude that extensive properties are exact differential, which are represented by dz, and these are state functions, that is z is the function of x and y, and the cyclic integral of these exact differential is also 0. Besides these, if we can use the thermodynamic property Q and W. Q is that is in the first law of thermodynamics. Q and W are not state functions, they are path functions. So Q and change in Q and W can be write as del Q and del W, that is partial differential, not complete differential, dE, dQ and dW, and these are inexact differential, and also cyclic integral of inexact differential is not equal to 0. Here it is important that the difference of these two inexact differential, that is shown in the equation, that is delta q minus del q minus del w is equals to dE. As the first law of thermodynamics, dE is an exact differential. The difference of two inexact differential, that is del q and del w, is called dE, and dE is exact differential. It is state function, it is extensive property, and the cyclic integral of this dE is called 0. So you can understand what is exact differential, what is inexact differential. Exact differential is a state function, are extensive properties, cyclic integral is 0. Inexact differential are intensive properties and their cyclic integral is not equal to 0. In the next topic, we will study the concept of work and heat. Thank you.